Problem 22. What is the maximum value of the following expression for all real values of t? So when you have questions that ask you for the maximum value of a given function, calculus, well, that's obviously a no-brainer. But if you don't know calculus, then another way, 99.95% of the time, you have to use the AMGM theorem, which basically says that the arithmetic mean of a given data set is always greater than the geometric mean of that data set. So with this understanding, I'm not going to be giving a rigorous proof on this. You can simply search it up, but basically this is always true for any given data set. And anyway, given this understanding, how are you supposed to approach this question? Well, when you want to find the maximum value of an expression, you always want to manipulate it in a way that you can rederive that expression in another way. What I mean by this is, for instance, if I x squared plus 2x plus 3, I want to say, hey, what is the maximum value of this? Then I want to rewrite in a form where I can have like a is greater than x squared plus 2x plus 3. And that takes intuition. But from practice, you can say that if I were to treat it as AMGM, what terms can I have? 2 to the t minus 3t and 3t. The reason why I think of this is because if I were to add them together and get the mean, I eliminate 3t. But if I were to multiply them together, I get what? I get 2 to the t minus 3 to the t times 3t. And that's very similar to this expression, which we can get by just simply multiplying it by 1 over 3 times 4 to the t. And then if you were to cancel, we get 2 to the t on the left side, and then square, and we get 4 to the t minus 1. So immediately I see, oh, that should be a plausible solution to this. So from this guesswork, we can try it, right? We can say the terms are 2 to the t minus 3 to the t. That's the first term, and the second term is 3t. So from here, what is the mean? The mean is equal to 2 to the t minus 3t plus 3t over 2, which gives 2 to the t over 2, which gives 2 to the t minus 1. And then for this case, what do we get? We get what? We get, or the geometric mean. The geometric mean is just a square root of 2 to the t minus 3t times 3t, and then that's the second square root, so we don't need to write anything else. From this expression, we want to square it because, again, this form is already similar to the original form, so we get this squared, so that squared, and then this squared, which gets us 2 to 2t, 2 to t minus 2 is equal to 2 to the t minus 3t times 3t. All right, I'm running out a little bit of room here. But nonetheless, we have this equation, but I can do one better. 2 to t minus 2 is equal to what? 2t minus 3t times 3t times 1 over 3 and 4 to the t. Remember, the logic behind this is that we want to rederive the original equation. So this gets us to that point. So we multiply this by 1 over 4 to the t times 3. And don't forget, that's supposed to be greater. So that means we have what? We have now, that's 4, so we can write this in terms of 4, right? So we can put this into 4t minus 1. So that means 4 to the t minus 1 over 4 to the t. Oh, that's just equal to 4 to the negative 1. So that's equal to 1 over 4 times 3 gives 1 over 12. So that means the original expression, 2 to the t minus 3t times t over 4 to the t, has to be less than 1 over 12. So that means 1 over 12 is the largest value. You can think of it as like some random function, but then as it hits 1 over 12, it has to dive down. So that means 1 over 12 is our answer, and we get choice C. Now, I want to say something here is that when you want to approach questions like this and get intuition for, I want to rederive the equation, that takes practice. And really, the only way to do that is to really do AMC textbooks, which AMC Volume 2 does a very good job of explaining. But nonetheless, that's the answer.